So in the Kubernetes world, there's this really wild idea starting to pick up steam. What if we just deleted all native Kubernetes secrets? The whole idea is to completely ditch them and use a dedicated tool like HashiCorp Vault instead. I mean, it sounds cleaner, it sounds way more secure, but is it actually a good idea or a huge mistake?
All right, let's really get into this. Picture this. Your cloud architect comes over and drops a new mandate. From now on, no more Kubernetes secrets. Zero. Everything is going to be fetched dynamically, on the fly, from Vault at runtime. It is a super bold plan, right? It's all about centralizing your secrets and beefing up security. But what happens when that perfect plan smacks into the real world?
So, here's how we're going to break this all down. We'll start with what we're calling the all-vault vision. You know, why it seems so appealing. Then we'll talk about what happens when reality hits. After that, we'll dig into a bigger question. What does secure even mean here? And finally, we'll land on a sane, balanced approach that you can actually use.
Okay, so first things first, let's give this idea a fair shake. This plan doesn't just come out of nowhere. There's some powerful, really solid logic behind wanting one single, authoritative place for all of your secrets. And you know, the goal is actually pretty compelling. If you only use Vault, you centralize everything. No more stale or duplicated secrets just hanging around in your cluster. And in theory, that shrinks your attack surface and gives you way tighter control. On paper, this looks like a massive security win. And when you put them side by side like this, you can really see why that Vault-only vision is so tempting. I mean, look at the left. Kubernetes secrets are, well, they're just base64 encoded strings sitting in etcd. But on the right, you've got Vault. We're talking dynamic secrets created on demand, awesome audit logging, super fine-grained policies, and automatic rotation. It's just a way more sophisticated system. But, and this is a huge but, here's the catch. This beautiful, clean theory runs headfirst into a very, very messy problem. The Kubernetes ecosystem just wasn't designed to work without its native secrets. And this, right here, is the absolute heart of the problem. See, you can refactor your own apps, the ones you build in-house, to talk to Vault directly. That's fine, but you can't do that for the hundreds, maybe thousands, of third-party tools that make Kubernetes so powerful in the first place. They're all built on one fundamental assumption. Kubernetes secrets will be there for them. And this isn't some minor issue. This problem is literally everywhere. Just think about the tools you use every single day. Operators that automate your complex apps, they're often hard-coded to look for a specific secret. Helm charts, the package manager for Kubernetes, totally reliant on them. Pretty much every community app you might pull in is wired to look for a Kubernetes secret. If you try to fight this, you're not just fighting a tool, you're fighting the entire ecosystem. So, people try to get around this, right? And a popular tool is called the External Secrets Operator, or ESO. Its whole job is to pull secrets from somewhere else, like Vault, and sync them into your cluster. And it's great. It works really well. But here's the beautiful irony. At the end of the day, it still creates a native Kubernetes secret. So if your grand plan was to get rid of them completely, well, so isn't your final answer. You know, this whole debate kind of forces us to take a step back and ask a much, much bigger question. It's less about the specific tool you're using and way more about the security principles underneath it all.
Exactly. This is the question. What is the specific threat we are actually trying to solve by nuking all our Kubernetes secrets? If the answer is just a fuzzy, for more security, it might be time to pump the brakes and rethink the whole thing.
Look, here's the blunt truth. Once an attacker gets control of a running pod, your secret is gone. It's compromised. And it doesn't matter one bit if that secret was magically injected from Vault at runtime or mounted from a regular old Kubernetes secret. To be used, the secret has to live in the application's memory, and if that pod is breached, an attacker can just dump that memory. Game over.
And this quote from the community discussion just hits the nail on the head. It says it all. If an unauthorized user has the RBAC permissions to just read secrets directly from your cluster, then arguing about Vault versus native secrets is, well, it's kind of rearranging deck chairs on the Titanic. You have much, much bigger problems to solve first. And that brings us to a really key takeaway. Real security isn't about picking the one perfect magical tool. It's a whole practice. It's built on solid processes, super strict RBAC policies, and just good old operational discipline. The tool? That's just one piece of a much, much larger puzzle. All right, so if the pure Vault-only approach is basically a non-starter in the real world, what should we do instead?
Let's talk about a strategy that actually gives us the security perks of Vault without breaking our entire workflow.
I love this real-world example. A user from a bank, an industry that is obsessed with security and regulation, shared their setup. They use vaults as their central source of truth, absolutely. But then they just use the external secrets operator to sync those secrets into Kubernetes when an app needs them. It's a hybrid model, and in their words, it's completely fine. So let's just walk through this sane, practical strategy. Number 1, absolutely keep Vault as your single source of truth. That's a great idea. 2, use a tool like ISO to sync secrets into Kubernetes, but only for the apps that actually need them. 3, the community consensus is to avoid complex sidecar injectors unless you have a really good reason. And now for the most important points. Lock down your cluster with rock-solid RBAC. Don't get obsessed with this idea of runtime-only fetching. And always start by asking, what specific threat am I solving right now?
So the bottom line is pretty simple. The best secrets management strategy isn't the one that's most pure in theory. It's the one that's pragmatic. It has to work reliably with the tools your team already knows and uses. It has to be secure through multiple layers. And frankly, it has to be sane enough for you to actually manage day-to-day. And that leaves us with one final question for you to take back to your team. When you look at your own approach to managing secrets, are you chasing some kind of pure architectural ideal? Or are you building a practical solution that balances top-notch security with the messy realities of the ecosystem? The answer might be more important than you think.